Looks like everybody's happy and you had a little cake. Let's give a round of applause to our sponsors again for that nice lunch break. Okay, to kick off the panel this afternoon, topic of applying artificial intelligence for information advantage. Today's moderator is Mark A. Mollenkopf, science advisor, another smart guy, to the commanding general, United States Army Cyber Command. He retired from the Army in 2019 after 31 years of service, and he was a command chief warrant officer in various places for Cyber Center of Excellence, Army Cyber Command, and U.S. Cyber Command, Fort Meade, Maryland. He has a bachelor's degree in liberal arts from Excelsior University in Albany, New York. I'm sure he'll talk about all the certifications that he has too. Let's give him a round of applause and the rest of the panel.
Awesome. Thank you, sir. Really appreciate the opportunity to be here today and to talk about artificial intelligence. It's a wonderful topic for this panel. At Army Cyber Command, we are taking a look at artificial intelligence as the great force multiplier if we can implement it just right. So I would also like to extend a hearty thank you to General Brown and General Smith and the whole AUSA team for making this possible today. Okay, we've got an electrifying discussion today on the topic of artificial intelligence, where the machines are getting smarter and the humans are getting, well, they're getting better at those tedious little CAPTCHAs. Yes, that's what we're getting better at. So we've gathered a panel of experts who will unravel how we can best leverage AI to make sense of the enormous amount of data that's being generated by our weapons platforms, our intel platforms. So sit back, relax, and let's dive into this technological adventure. I'm going to start off by just doing a very brief introduction to some of our panelists. To my immediate right here is Major General Matt Easley. He's the Deputy Principal Information Operations Advisor to the Undersecretary of Defense for Policy. In this role, he leads the Information Operations cross-functional team as it conducts a posture review of the department's information forces. Dr. Jeff Rogers is a physicist. Raise your hand, Jeff. Is a physicist and applied mathematician and microsystems engineer with 3 decades of technical leadership and experience in multinational corporations, government, and academia. He's currently focused on digital health at IBM. Thanks for joining us today. And Mr. Sami Akbay, raise your hand, Sami. Thank you. Sami is the group product manager at Google Cloud, focusing on the data analytics portfolio. And he's been working with data since before data was exciting. He's held many positions across Europe and Asia, and he's an avid proponent of real-time architectures and doesn't like to batch process data. He believes in high availability so much that he carries 2 cell phones with him at all times. Dr. Matt Gaston, raise your hand, Matt. He's the director of AI at the Software Engineering Institute at Carnegie Mellon University, where he's also an adjunct professor in computer science. Welcome, Matt. And finally, Mr. Kyle Fox. Kyle, raise your hand. He currently serves as the Chief Technology Officer at SOSi, the largest family-owned federal services integrator. Prior to his role at SOSi, Kyle held key positions such as Chief Software Officer for the United States Air Force Nuclear Weapons Center's ICBM modernization program. So thank you for joining us, Kyle. All right, now that the introductions are out of the way, we're going to get right to the questions. And I'd also like to stump for some questions near the end. So as we get towards the end, if something jars a question loose in your mind, please jot it down and get it to us, because we want to be as interactive as possible with the audience. Okay, let's get right to the first question. I'm going to start off with Dr. Jeff Rogers. Question number 1. How can AI, including large language models, we have to make sure we're including LLMs here, how can AI be used to improve intelligence gathering and analysis? What are the compelling capabilities you know about today, and what's coming next? Over to you, Jeff.
Question. Simple answer. So look, I think there's a lot of places where general techniques in AI work well. In particular, when you think about systems where, and you all know this, you've heard this, but I'm just going to call it out a little bit, where correlations aren't obvious, right? Where there's signals in there that aren't something you would necessarily pick up. Certainly, sometimes that's a temporal signal, right? So if something would be, let's say, in the noise usually, or there's a lot of noise because, you know, the vehicle you're in is rolling and you're not getting a lot of fine resolution, but something like AI, different techniques are pretty good at picking those signals out, right? And so in an intelligence situation, that would allow you to, you know, pick up a signal you wouldn't even see. It would be in the noise floor and you can pull that out. So I think that's one place where you have a lot of interest or a lot of applicability where you could make a difference. But there's a lot of hype right now about AI in general, but in particular, there's a lot of enthusiasm for good reason around all the things that have come out with, you know, what you would call foundation models or, you know, the chat GPT and things like that. And, you know, this really is a sea change for us, right? With generative AI and these ideas at this scale. And so there, I think it's important for people to realize that, yes, these things will be good at time series, right? But what they are based on is large language models, right? So this is about, I have this sequence of words, what's my next word? And these models are incredibly good at that. And that's what you're seeing from ChatGPT. So if you want to think about where do I need to understand language, okay, in an intelligence context, not just, okay, maybe I have some missing words and I can fill in the gaps and know what they were with a high degree of certainty, but actually you start to think about being able to infer from what somebody has said, what they actually meant to say, right? In a way where, okay, is this person trying to make another point, but they're using a set of words, what's the meaning of what they're saying? What is their mindset? Getting all the way to kind of cognitive state itself, right? So that's something we've never been able to do. We can actually do that to some degree now. And I believe that's a place where it's going that might be relevant, which is around, you know, when you're speaking, right? That's a direct reflection of how your mind is functioning. And there's a lot of cues in what you say that these large language models can actually pick up. So even if someone is being deceitful or intentionally, or maybe they don't even mean it, right? But they're trying to get across a different message. That's something that you could actually pick up using these large language models that have been developed. And they're not being applied that way really yet. We have applied them that way in some cases around trying to understand what people are telling us in text. And they've been really successful. Comparing them even with clinical measures, it's actually turned out to be right. And so I think that in this community, right, that there's a potential for a lot of progress there that you wouldn't expect. I would say though, look, this is an area that's moving so rapidly, right? And so I think that's a challenge is how do you work with, you know, the companies and the places that are making the innovation? That's always been a problem for the military, and that's one here. And certainly the place I see the greatest opportunity right now, actually, I think is around language. So I think that's what I would point to most.
Okay, now that's a really helpful insight. Let me pitch it over to Sami. Any thoughts there?
I agree with everything Dr. Rogers said, and I'll take a easier question if possible.
Absolutely, absolutely. So, you know, one of the things that General Barrett talks to the staff about often is reducing the complexity for the workforce, because we can't continue to scale people, adding to the number of systems and the added complexity of having additional systems. So Sami, how can we use AI to reduce complexity and reduce the number of tasks for people?
Well, for starters, at Google, we actually have quite a few of the technology that we talk about in what we call a dog food program. So we have to use it ourselves before we release it out in the wild. And Yeah, so for example, if I'm reading a document, I have the option to ask, can you summarize what this says? And it will do a pretty good job. Sometimes, I mean, if it's coming from my boss's boss, I'll actually read the whole thing. But if it's if it's coming from my peers or a lot of other people, I'll just like look at the summary of any conversations that I've missed. It allows me to process a much larger amount of information on an ongoing basis. Now, the downside of that is because I'm getting so much more information throughout my workday, I do a lot more context switching, and it's kind of more exhausting by the time you get to the end of the day. But the other end of it is I can write some bullets and I can tell the system, can you actually draft this to be more formal, or can you draft this to be more concise? And it will do a relatively good job. So productivity-wise, it really changes how much individuals can produce, but it also kind of pushes you to become better at prompting the system and giving it the right clues so that it becomes useful for you. One of the things earlier that I actually mentioned in our ready room was that I changed the default meeting time on my calendar from 30 minutes to 15 minutes because it forces, I mean, having all this productivity technology in your life forces you to be more efficient, and you can go through more in a more constrained amount of time.
Now, that's an interesting perspective. I mean, getting more people time back for people to be able to execute higher order tasks, that's definitely something that I know our boss is interested in, and I know we're looking forward to being able to leverage that as well. Okay, let me ask a question to Major General Easley. As the Army pursues the concept of information advantage to achieve decision dominance, what considerations should be involved in the Army's application of AI for information advantage?
Thanks, Al. Great question. Since the title of this talk is Applying AI for Information Advantage, I figure I should spend a couple minutes talking about what information advantage means to the Army. In my current job, the Army has helped me a huge amount since they have refused to accept information as a joint function. They refused the concept of operations and information environment. But what we have today in the Army is a kind of migration from our legacy information operations of how do we combine different information effects to create the synergies we want for our operations. And the new construct that we've created is what we call information advantage. But like the old contracts and the new contracts, the goal is the same, that we want to create the conditions that we have kind of the initiative in the information environment, that we can see ourselves, know ourselves, and act faster. Just kind of the old traditional boys OODA loop from many decades ago is how do we get that same kind of concept in the information space. The first kind of pillar of the Army's information advantage is to enable decision making. We want our commanders, we want our staffs, we want all our soldiers to be able to see ourselves and think what should I do next in this environment. We also want to protect ourselves. We want to protect our friendly information. And this is more broadly now than just our traditional concept of operational security. We really need to understand what the attack surface is that we're facing in this new environment when you have kind of ubiquitous surveillance on everything you do, from overhead assets to online kind of digital tracking. We want to be able to inform and educate our domestic audiences. We need to be able to tell the public what we're doing and why we're doing it in clean and concise terms. But we got to be able to inform and influence foreign audience as well. We need to tell the world what we're doing. And then finally, we need to conduct information warfare. We want to make sure that our adversaries can't do information operations or operations information environment as well as we can. You can imagine that all 5 of those areas can use artificial intelligence and machine learning to some effect for those. Mostly in this space, we can just talk about how do we see ourselves. And you heard this from the first 2 questions. I mean, how can we use these tools, again, to make decisions faster and better? For my time at the Army AI Task Force, the 2 key enablers that kind of were slowing down our adoption, and I'd love to get the input from other panelists on this, is twofold. One is migration to a hybrid cloud environment. Army's going to continue to have lots of legacy data centers, but as we need to surge, we need to move around the world, cloud environments make this much, much easier for us to do global operations. And we have to just know that we've got to move our IT infrastructure into that environment, just so it can get all the advantages, the economies of scale that all the cloud providers can provide us. Second, and I've heard General Baer talk about this at length as well, it's mobile devices. 85% of the world has a smartphone. It's something like 5 or 6 billion devices in the world. And that's only, that adoption, as we start including Internet of Things, that adoption is only going to increase kind of this attack surface. So, I mean, again, these come with a lot of features. They come with a lot of vulnerabilities too. And we have to think and use artificial intelligence, I mean, again, both to defend ourselves as well as to just to manage the huge amount of data that we have there. For soldiers, I always saw kind of 4 tasks where soldiers can be involved in helping leverage AI in all these areas. One is to collect data, collect and annotate the data. If you think what cell phones are doing every day, either explicitly with you or implicitly as you use the phone, it's collecting data on you. We have to figure out how to, and for our cyber operations, yes, we collect that data on all our endpoints, all the pieces of our cyber operations. We do a great job with our big data platforms to do that. But there's still lots of data in the Army that we are not capturing fully. Everything from key leaders engagements to General Easley giving a speech, all these pieces that we can use to, again, train our own large language models. So collecting data is huge. Then we need to use that data to train models. Again, we've talked a little bit about large language models, but to make these models effective for our domain, we have to train it on our data. So we have to look at what is our human resource data? What is our medical data? What is our operational data? What is our intelligence data? How do we use those, I mean, in a controlled environment to make better models? Then we need to use those models and see if they're effective. Some other talks, and you may have talked a little or heard about DevSecOps pipelines. In machine learning, it's even faster, that you have to be able to have these systems train and retrain on a much, much more rapid pace and much more automated pace. And then finally, we need soldiers to help improve these models. So as the models get used in the world, you have to look at them and improve them. I like to talk about my restaurant recommendation algorithm on my phone. The reason it's so good is because it's got 10 years of just me telling it what restaurants I like in the world. So when I go to any place in the country, I get a good restaurant because I've already trained my algorithm through the help of some of the tools out here. So
yeah. Anybody else thoughts on that, Kyle? I was looking at you when you start talking about the self-trained models.
Yeah, absolutely. I'll touch on 2 things. I think hybrid cloud is a great topic to touch on. So what we're starting to see is the need for distributed compute. This idea that we have these platforms that sit out there that are pretty static. They don't really change, whether it's an IT system, a OT system, or otherwise a weapon system. And we're starting to see a significant shift with that. This idea that we need to be able to move flexible baselines to those platforms, be able to take advantage of the data that they're generating. And then going back to that training, but we need to have a way to address the resource needs of training. So if you look at the investment that Google and others have placed in it, it's immense. Some of the largest supercomputers in the world now are related to large language model training. And those things have cropped up just in the past few years. So it's not practical for us to take the $1 billion investment and replicate that on the edge, but there are techniques for us to take some of that, replicate it up to sovereign cloud, and then again, with flexible compute on the edge, be able to take advantage of that fine-grained learning in a very safe manner.
Yeah, that's really important. The edge really matters. And as General Easley pointed out, I mean, the bottom line is a lot of countries are developing and evolving mobile only, not just mobile first, mobile only. So distributing artificial intelligence capabilities to cell towers and to the edge in unique ways, that's going to be something we're going to see in the future. So continuing on that theme, Mr. Fox, let me ask you a question. How does data creation location, especially as it pertains to weapon systems, weapons platforms at the edge, and home station impacts, how does all of that impact AI and machine learning? What underlying plumbing is going to be critical to being successful as the Army implements this?
Yeah, absolutely. We touched on that a little bit, but let me back up 1 second, then we'll take another run at it. One of the reasons why we're seeing panels like this is what's changed is the way that we interact with data and the underlying AI capabilities. We've talked about large language models, and they come up so often because it's a much better human-machine integration. Now we're able to interact with these very complex models in a way that's very simple. And that's now the new table stakes. That includes the way that not only we do business, but the way that we conduct warfare. And so for us to be effective to this, we need to take all the data that's present on these platforms, and every generation that we see an update to a platform, there's more and more signals that are provided, more and more sources of data. That's great. Data's wonderful. But to make it effective and to tie it into these models, we need to look at, again, these systems not being, these edge devices not being a static thing that goes through a many month or in some cases multiple year ATO, but instead something that's continually updated and modernized. Now, to do that safely, we need to really look at techniques like providing zero trust all the way out to the edge. And that's not something that's a buzzword. It's bringing practical experience to it. Indo-PACOM has some really interesting examples in this in the MPE environment work that we've done with them, where we're able to look at providing a lot of granularity at who's allowed to change the data, how is the data being influenced, down to a service-to-service interaction. That lets us then safely interact with that data, have coalition partners safely interact with that data, and then make those results shareable and usable in broader data sets. We also need to look at the way that we provide these overlay of networks. We need to move away from the model, and there's already significant progress towards this, from a series of individual networks to networks that work in concert with each other. It's really exciting to see Army's UNO effort, right? This is a really good example of how we're trying to look at all of the current networks that are bed down now and make them work as a functional unit together, being able to take advantage of whatever is the best link, whatever is the best piece of compute, and using it in one harmonious system that is just, it just works. It's invisible to the end user. The system is smart enough to know how to make that operate.
Awesome. No, that's great. And before I head over to Dr. Matt Gaston for question number 5, I want to hit Sami up on one thing. You know, there's been a lot of innovation around the web browser, which, you know, Google's been kind of at the forefront of. One very interesting aspect of what we're able to do to push machine learning to the edge is we're able to leverage inside of a web browser the shaders. We can mimic a GPU using these shader software routines. So that's enabling us on a mobile platform, as General Easley pointed out, on a mobile platform, leverage the ability to actually create models and chew through data at the edge in ways that have not been thought of before. So, Sami, let me pitch it over to you. What are you optimistic about in this area at the edge?
So we keep saying it's different this time because AI has been around since 1950s, and finally it's actually different this time. And the reason that it's different this time is a number of different things. First of all, we now have practically unlimited storage. And we also have tremendous compute capability, and this compute capability is separated from storage. So we can take data, we can overlay storage, we call it serverless, or we have like a lot of different architecture terms. But in essence, you can take data and you can put compute on top of that data, however you need it. And big data, which has kind of come about in the last 10, 15 years, has changed how we store and process information. In the past, you would take periodic snapshots, think of it as photographs of something, whereas now you have a videotape of everything. Because you have such a large set of data and you don't have just a sampling, suddenly the whole kind of statistical model starts to shift. You can actually look at complete sets of data, and because you're looking at such a big set of data, you can start looking at these correlations rather than trying to figure out why A caused B to happen. You can just look at the correlation between A and B and get meaningful results. So instead of having causality, correlation can start driving meaningful outcomes. And you don't have to just do reasoning, you can do statistics to get meaningful outcomes. Now, how does that tie back to edge versus central? Like, starting from 1960s, 1970s, where we had mainframes, then client server, then Web 1.0, Web 2.0. It goes back and forth. We move compute to the edge. We consolidate it back in central locations. The thing that's happening with the current generation of machine learning and AI models, we have a very centralized model still. And those centralized models are built upon very large and very complete data sets. So the correlations and inferences that you make against it is accurate and meaningful. At the edge, you have a limited amount of information that only sees a sliver of the world. So a model that you create out of it is not going to be complete and likely not give the results that you want. So probably this transition is going to take a path where centrally you create the models, and these models are generated against very large sets of data that collects information from all parts of the world, all parts of your edge devices. And once that model comes up with meaningful results in a sanitized test environment, you push the model to the edge. And events that are happening can be evaluated and inferences can be made against more complete data sets. So I think the whole back and forth we're going to keep seeing for generations to come. But models may be generated at the center and then pushed down to edge devices for very rapid, very accurate analytics.
So can I just weigh in on this for a sec? I'll break the stream.
Yeah, no, go ahead.
All right. So I think you're making some really good points, and it's important that everybody understand, look, AI is not magic. What's different now really is we've got compute, we have memory, right? And basically unlimited levels to some degree. And that's amazing. But really what's amazing that's happened most recently is the idea that you're separating all the AI techniques, from whatever one you want to pick, was always dependent on having lots of data. The more data, more better, right? And that's a pain. That's very difficult to do. But we've reached a point now where kind of the big data pieces have separated, right? So these foundation models are much more around, I can train a very large language model, an enormous model, and then I need just a little bit of data, a much reduced set, to make a meaningful cut down of that big model for my application. So for the military applications, I think this is a real change because, you may have a few signal detection events of a system that you want to pick up, but you don't have a lot, right? Not enough to train a big data model. And so now you don't worry about that. You actually have a good foundation to start from. If you have a meaningful small set, you can apply it and get all the advantages of an enormous model, but on a small training set. You can move that to the edge, right? And that is a very plausible thing. You don't need to move all the data. You need to move a small model. I think that should be a sea change for the applications as far as intelligence.
Yeah, no, that's a very interesting perspective, and I think that you're spot on. I mean, at the end of the day, we've got to get the data models to the edge, where the data is and where the decision is being made for tactical operations. So that's a great point. Let me pitch a question over to Dr. Matt Gaston. Matt, combat leaders have perpetually complained about the lack of information. It undermines their ability to make decisions at the tactical level, at all levels. So there's not enough information to make decisions. But now we're starting to see a little bit of a pivot back to now there's too much information. So how can leaders today, how can they use artificial intelligence, machine learning, that sort of thing to optimize their decision-making process?
Well, first, thanks, Al, for having me. It's an honor to be up here with the rest of the panelists, and thanks to AUSA for the event. I thought it was ironic that this question fell to me, the academic. Tell us what the commanders really need. It does turn out I'm really not an academic. I'm at a government research lab at Carnegie Mellon University, and I did spend 10 years in the intelligence community, and I was an Air Force officer. Sorry, I know it's brave for me to say that here. So I have a little bit of understanding of the military.
We'll keep you on the panel. It's okay.
First, I want to emphasize, before I get to the question about what the commanders need and how to use these technologies, I want to emphasize what we just heard from the last set of comments, you can run a large language model on a edge device. This is a supercomputer. It's got a whole lot of processing in it. It's maybe not analogous to what every soldier is carrying around, but it doesn't have to be that far off to getting that level of computation in the hands of a soldier, of someone on the edge, of a commander in the field. And you can run these large language models and lots of other AI technologies on them. Okay, so to the commanders. So first I should say I'm an AI optimist. I always say that because I talk a lot about AI failure, but I am an AI optimist. And remember that AI is so much more than just large language models. But for commanders and what they need and information requirements, I think where the military is, where the intelligence community is, we've built exquisite sensors. We can collect so much data about stuff now, about self, about others. We can have lots and lots of information. Where the opportunity with AI is to start to organize. I can use the big words like understand, but I feel like that's not very satisfying. So organize, prioritize, let data find data. I already said summarize. It's not just about more data. You don't always just want more data. It's maybe find the data you want or connect the two dots that you need to connect. And the gamut of AI technologies can be used to do that. I want to get to a really interesting point that maybe weaves through all of the questions. We talked a lot about getting the data right and those sorts of things. I challenge the leadership at CDAO, not the actual CDAO, not Craig Martell, but folks in the leadership at CDAO recently, because they said in the hierarchy of needs for AI, data is the foundation. I actually think there's a level down from there, and I think it's instrumentation. And I would ask Sami from Google. There was a great paper by Google's chief economist years and years ago, Hal Varian, called Computer-Mediated Transactions. And that paper basically argues that instrumentation is the key. If you instrument everything, including the human interactions, including the commander's interactions with the information, maybe that's not the commander themselves, but through their staff and everyone that's supporting them. If you instrument everything, you're starting to see the decisions that are being made, the priorities that are getting made. And that information can be used to build models that can help prioritize information on the battlefield, sift through all of that data, and give commanders and their teams the information they need to make great decisions.
Okay, no, that was awesome. I really appreciate that. Anybody else want to pile onto that before I go to the next question? Going once, going twice? Okay, let me go ahead and go to the next question. Major General Easley, this is a tough one. Okay, so where do humans fit into this as the Army tries to figure out how to implement artificial intelligence to accelerate its ability to wield information advantage?
So, I mean, great question. You probably have heard the term like human in the loop, human on the loop. It all depends upon kind of the speed of the decisions and the severity of the decisions that have to be made in this space. For a lot of our weapon systems, obviously, it's going to be human fully in the loop, managing the system. Yes, they may get some recommendations. Other systems, I mean, where it's not as critical, the machine can make the decision. I mean, we have these today, and all these systems, even the ones on our cell phones. I mean, you don't question your mapping algorithm telling you where to move through the city. You know that algorithm has better information than you do, and you effectively trust it. But I think that kind of leads into that trust question is how do we, again, get the veracity behind the data that we can trust what went into the model, then how the model was trained, and how we're using it. And I think that's all, I mean, human endeavor and all those pieces.
No, awesome. No, I really appreciate that insight. Let me ask Kyle. Kyle, you are uniquely experienced in the trustworthy compute area. So let me ask you, where do you see the role of people and reduction of complexity in that area?
Yeah, absolutely. So trust is a fun thing. So prior to this, I was involved with the nuclear weapons community, and you talk about trust, right? That is the definition of zero trust, or I like what Josh calls it, no trust. So the way that we built the no trust environment is we started at the foundation. We started out with how do we start to introduce things to an environment that we know with a high degree of certainty, whether it's math, whether it's other policy ways of knowing that works. And then we slowly build things up over time so that that system is trusted as it operates as a fully fledged system or system of systems. And I think AI is like that. AI, we're going to need to do much better with transparency. I really like the work that the NIST 800 to 18 folks are doing with SSDF, the Secure Software Framework. And SOSi is supporting this work with this idea of self-attestation. And what they're doing is folks that are contributing in the software environment, there's a listing of kind of what are the components of this software, what's involved with building the software, who built it, motivations, et cetera. And then as this component gets built with all these little pieces, software bill of material, et cetera, you now understand with a great deal what comprises this system. And then it lets the individual mission owners be able to adjust on, does it fit their risk profile? Is it serving a nuclear weapon or is it a toaster oven? Right? Very different risk profiles, and it gives that mission owner the opportunity to choose.
Awesome. No, that's really good. I tell you what, we're going to shift gears here. We've got a couple of questions from the audience, and I'm going to go ahead and address a couple of these. This first question is for Sami Akbay. Sami, your LL-driven dialogue sounds like my idea of hell. How do you focus on anything? How do you really learn anything? And I'm not going to mention the person's name that said that. Sydney. Okay, so Sydney, did I get that question wrong? I'm sorry.
Yeah, no, I mean, LLMs hallucinate, first of all, but even when they're right, they're generally bland, lowest common denominator, studiously turgid, like the worst PowerPoint briefing you've ever gotten inside the Army, and I've gotten some bad ones. So I can just see you at your 15-minute meetings reading the cliff notes on things intelligent people actually said, computer-generated cliff notes, and I can see your IQ just probably about 250 in the morning, getting down to about 50 by the end of a day of that. That sounds like literally something that Skynet would devise to lead to human extinction. How on earth do you avoid commanders making themselves incredibly stupid by doing what you do every day? It sounds horrible.
But before, yeah, no, that's a great question. We really appreciate that, Sydney. We did talk about context switches. Sami, go ahead.
Yeah, I'll take that. But tell me how you really feel. No, I think there's a lot of truth to what you kind of summarized here. Hallucinations is a real problem. Factuality is a problem. But there's actually the foundation models, and these foundation models create a conversation. And in different ways, we have to make them accountable. You can't just let the system have a conversation that's pretty intelligent. So when we're doing the inference, we're really kind of trying to curb it from saying anything and everything that it thinks, because there's a set of guidelines that we self-impose on the technology so that it abides by a set of kind of ethical principles, right? Now, when you implement LLMs, you have the foundation model, then you put your own information on kind of corpus of data on top of it. When you do that, there are a few things that you think about. One of them is you need to control your IP, and it needs to be factual. It needs to give you the right choice and value, because you don't want to ask a 10-cent question and spend $5 to answer it. You need to have security at scale, and also it needs to provide some level of ease of use. But on the back end of it, pretty much everything that we put outside to the world has to abide by these, what we refer to as AI principles. It needs to be socially beneficial. It needs to avoid creating bias. It needs to be built and tested for safety. It needs to be accountable to people. It needs to incorporate design principles so that it does not identify groups of people that might be put in a risky situation because they've been identified. It needs to also uphold highest scientific standards, so it does not tell you something that it shouldn't. And when you put all of these together, the technology is very much curbing anything and everything that it wants to say to you, right? It's not going to just go and have wild conversations with you. this is going to get incorporated and it's going to change the way that we interact with computers. But currently, I don't see LLMs as your trusted advisor, or I don't see LLMs as something that answers all the questions for you. It just presents it in a different fashion that you can consume with a lot of caveats around it. It's going to get much better. I mean, when you look at a lot of the technology, including our search, for example, 15, 20 years ago, it wasn't nearly as sophisticated as it is now. Over time, it's going to get better, and things improve at a much faster speed than they ever have. So I'm sorry that your experience with it has been less than intellectually stimulating, but it's still cool.
I've hardly used it, but I used it to profile some people interviewed about it, and it got their bios significantly wrong. But okay, you have two things at war with each other, and the temperature setting sort of embodies this, right? You dial up the temperature, the computer is allowed to do more things, generate more tokens, more next words in the sequence that are low probability. Like, World War I started in 1914 is your 90% answer. 1913 is your 5% answer. 1901 is your 1% answer. But you can make that can lead to a really interesting argument. But if you dial down the temperature, so it always chooses the most probable word, the most consensus word, the lowest common denominator word as the next token, you prevent hallucinations, but you also make sure it is dumb as hell. So I don't see how you, with a transformer architecture, I mean, I'm not an engineer, obviously, but I don't see how you square that circle. How you get something that's, it either hallucinates because you're giving it freedom, or it doesn't hallucinate and it gives you absolutely zero insight because you've squashed its ability to do anything that's not completely predictable.
That's a great follow-up. Let me pitch it over to Dr. Gaston to see if he's got some insights there.
Well, thanks, Al. Is it Sydney?
Yes.
I think I would recommend that you use these systems more, for one thing. You said you've only done minimal work with them. I would encourage you to interact with them a lot. And it was interesting in listening to your comments. You talked about dialing up and down the temperature, and you picked the two edges of the spectrum, right? The zero or the max volume side of the temperature dial. I think there's a lot of nuance in how you use these models. If you just ask them vanilla questions, you're going to get vanilla answers. But there's opportunities to fine tune these models to specific data sets. There's opportunities to do prompt engineering, not something I am actually a huge advocate for as a whole discipline of engineering, because I haven't wrapped my head around it yet, but you can get more sophisticated with your prompts. You can say, I didn't like that bland answer you gave me, give me something more sophisticated. You can say, I don't believe what you just told me. And it will, in some cases, some of the different models will try to defend themselves. There's also really, really interesting applications of these things. So I heard one just today. I guess I can't mention the source, but imagine your job is to find information in a manual, 1,000-page manual. You can actually use these language models to ask a question of specifically one manual, 1,000-page manual, and it can help you find the thing you're looking for in there. So it doesn't have to be this bland, boiled down, lowest common denominator interaction, but there might be some work to get them to operate the way you want and to get the nuance out of them.
Yeah, that's a great response. And I'll say, just let me pitch this over to Jeff. It's been my experience that, you can couple technologies together to optimize them. So take a large language model and filter the output through a knowledge graph, for example, to validate the outcome. So any thoughts or comments on using other technology to optimize?
Oh yeah, absolutely. I think and to the point, I think these larger models that have been now trained on so much data, that gives you a good foundation. And I hear the comments made from Sydney about how dumb it can be. And yeah, it is true. If you drive it towards the mean, you'll get a dumb response. But if you use it in the right way, with the right context, it can give you things you never expected, right? And so along with that, it's not look, AI today isn't general intelligence. We're not there. But the idea is we have some capabilities that can augment your skills that you've never had before. And I think exactly the idea that you're getting at there is, you have all these applications on the edge you want to do. you do not have unlimited memory on the edge. I'm sorry, you don't. And you don't have unlimited compute on the edge. And you can't train a large language model there, but you can take one that you've learned from and apply other tools to it, right, which are much more efficient. You should always keep in mind too, right, that the more sophisticated algorithms you use here, the less you can trace what they're doing. You know, correlation is not causality. So you can make a whole bunch of mistakes that way. And you can convince yourself of things that are completely wrong. But I do think coupling these techniques together, as you're alluding to, I think that's the way to really have some powerful applications that make a difference. But it's all about, you know, understanding where you're coming from and then what the application is, putting it together, which sounds, yeah, obvious, but that it's needed. Yeah.
I don't remember which one of you said it, but we are really in early days here with large language models. So the practical application of coupling some of these technologies, knowledge graphs, that sort of thing, the upside's huge. So great response. I have another question. This one is for General Easley. How does the Army buy artificial intelligence? Abazir, I don't know if you're out there. Okay, thank you for this question, but I'm not sure how we'll answer this, but over to you, sir.
Sure. For the Army, it has been a challenge. So one reason Army Futures Command stood up the Army AI Task Force was to start trying to address some of these concepts, or at least how do we even get frameworks for purchasing these products. The way they purchase these is it's a broad spectrum. I mean, you can think of everything from software as a service, where we go out to a company and we ask them, we really need this boutique space right here, and we wanted an AI model for, I mean, a medical application. I'm just as an example. Other ones, for example, aided target recognition on our weapon systems. We're going to want to hold that kind of technology close hold. We're going to have soldiers integrated, tied into it, so they can train their own models. Same thing with our cyber defensive models. I mean, there's going to be a kind of, a give and take there between what we want to use from the commercial aspects to what we want to keep on our own data. So from how we buy this, these systems are so encompassing. It's hard to say that. Do you just go buy the piece? Do you buy the set of tools to be able to build these? Do you go out and buy a no-code, low-code kind of system to help soldiers and our civilians build these models? It's a broad spectrum.
Yeah, absolutely. And I think that it's a wonderful question. I appreciate you asking it. The Army's probably going to have to try a multitude of things to get it right. But I think at the end of the day, with the help from our industry and academic partners, we're going to be able to bolt that on and make it drive our decision making. So thank you. I have a question, and this one is for Kyle and Jeff. So I'll give you a couple minutes each. How do you reconcile the need for transparency to foster trust with the idea that we don't need to understand causation to use the AI models? All right, that's a tough one. So I'm going to start with you, Kyle, and then we'll pitch it over to Jeff.
Definitely going to tag team this one. So it's critical that we understand the pieces that go into whatever capability that we're deploying, just so that we can understand it and we have these kind of conversations of when we say that we're opposed to risk on a system, what are we opposed to? What are we afraid of a hallucination, or are we afraid of a supply chain inject? Once we understand the nature of the mission, the nature of the system, then we can start to drive out controls or methodologies so that we can safely operate within that risk portfolio. Jeff?
So I think it's a wonderful example where controls help, right? Because I think that, look, you want to have, as was said before, I think in a lot of applications, you're looking for highest performance, certainly in the ones I'm aware of. And so in those cases, I would like to have it make mistakes, right? I want it tuned up high enough that it's making mistakes, but then I have a control system on it that is fixing some of those, right? So that would be, I think, a general approach to it. I think that you have to, look, big data does not solve all kinds of things. You have to be aware that some of the stuff you're getting is garbage, right? And so you have to create, I think, in a lot of these application controls around them, right? You know, we work on a number of healthcare systems right now, And we have these examples where we're sending signals right now to people's spinal cord stimulators that are dealing with chronic pain, right? This is incredibly, pulls at your heartstrings every day you work with the people, but you're giving them recommendations about what the signals they put in to try and alleviate the pain they're dealing with, right? And so you have to always check that that makes sense, because the system is making some predictions around it. And you have to always go back and say, all right, does this make sense? And I think that you have to have control systems in place with these models where that's true, because you don't have causation. You're never going to have it, especially as we get these more layered models. So I think that, yeah, general, that's the answer.
Okay, that's excellent, excellent response. I really think that that's spot on. So we're going to go ahead and we're going to pursue the last portion of our panel members. We're going to do a closeout where each one of you is going to get to kind of highlight a couple of thoughts that maybe I didn't, enable you with the opportunity to talk about. So closing statements by the panel members. I'm going to go ahead and start here with Major General Easley. Sir, any final thoughts?
Sure. I'd love to just talk. One topic we haven't talked too much about is the effects of large language models and kind of our cybersecurity framework. So we have a fairly, robust risk management framework that the DoD has been implemented for many years now. Kind of based upon the NIST framework. How does that framework change when some of the attacks are being much, much more tuned and sophisticated to given individuals? You've probably taken your cybersecurity training and you've studied spear phishing and whale phishing type attacks. With large language models, those attacks can be much, much more customized and much, much more automated. So we as kind of the cybersecurity professionals need to think how do we want to defend the force in this space, especially when our attack surface is so much bigger and people can reach out straight to individuals on their cell phones and tell them things that may influence how they act and perform.
Awesome. Thank you. Matt, over to you.
Thanks again, Al. I'll leave you with a thought of sort of where our focus is at the Software Engineering Institute when it comes to AI for defense and national security. Our focus is not on AI science, AI technologies themselves. It's on AI engineering. And really at the core of that is understanding how these systems fail and what to do about them when they fail. We are in the very early days of things like large language models. GPT came out in November, right? Things are moving very, very fast. And we don't really have a theory yet of exactly how they work, when they hallucinate, when they don't hallucinate. That's what we're after with our focus on AI engineering. And I think the thing, and maybe it gets to the question of how does the Army buy AI? And I can't tell the Army how to buy AI, but I'll offer a suggestion. We have to think beyond just accuracy. We have to think beyond just how well does it apply to a specific task or how accurate it is on identifying a particular type of object, and look at the trade space of all the different qualities. We might want to trade off accuracy for mission uptime. We might want to trade accuracy for robustness and other quality attributes. And so this phrase beyond accuracy, thinking beyond accuracy, asking for systems with requirements beyond just accuracy is, I think, going to be critically important to how these things get done on real defense and national security applications.
Awesome. Hey, Kyle, let's hear your closing thoughts.
Yeah. Okay. I think it's absolutely not the time to wait, but accelerate with AI adoption. It's something that we should look at. The platforms that we have today, we don't have to throw them away. We can work with out-of-band data and we can start doing experiments right away. And I'm rhyming too much. Anyways, I just encourage us to do industry consortiums, to do experimentation, and to learn together immediately. We'll find out together what these platforms can do, and that'll transform the way that we conduct operations. It transforms the way that we interact with our workforce. It changes the way that we even think about operating as a military. So it's pretty incredible stuff, and it's, again, something that we have to absolutely lean into.
Okay. Sami, over to you for closing statement.
Well, first of all, thank you very much for having me here. Earlier in my career, many of my mentors were retired Army people. So I have a huge affinity and appreciation for the service. There are a few things that I wanted to bring up. One of them is data ownership, data culture, and data architecture is going to be very critical in enabling AI, and also having a democratic application of AI across different ranks. Right now, unless you have a significant background in computer science and a significant amount of education, much of AI is still somewhat out of reach. And we need to make sure that we introduce the technology into a lot of different areas where it's not just the kind of people with PhDs that are driving this, but also people who know SQL, people who are analysts, people who are data engineers, people who are in the front lines should benefit from it as well. Otherwise, we're going to have a very skewed, biased haves and have-nots of data and data ownership. So everyone needs to get on board. And we have a duty as technologists to make sure that we don't leave anyone behind. The other thing that I want to kind of like, touch on is everything that we do needs to be coupled with ethics and guidelines that we implement, and we may have to do this as self-control. We need to be principled about it because things can get out of hand with some of the examples that, for example, General Easley mentioned. I don't want my grandmother to receive all these attacks, and this technology has, unless controlled, a lot of different ways that it could be misused. And at the same time, there's a humongous opportunity ahead of us. You can't hide from it. You just have to go head on and adopt it in the most kind of deliberate and most kind of thoughtful fashion possible. I'm very optimistic, and I think we're living at some of the most exciting times, and I think it's just going to get better.
Awesome. No, that's really insightful perspective. Okay, Jeff.
Yeah, well, thank you, everybody, for having me here and giving me the last word. That never happens in my life. I'm enjoying this. So the one that jumps out to me, right, would be force readiness, because there's so much information out there in different places, both about an opposing force, but even your own, right? And understanding where an opposing force or where yours is having problems, or has strengths that aren't obvious. I think that's an application of all this, which would have near-term benefit and allow for a lot better planning over where the gaps are longer term. So to me, that one we didn't touch on, but I think both in the health of people, but then all, do the other side have the materials they need? Are they supplied correctly? Are they ready to move, right, or not? And that's something, and then your own people, the same things. So I think that's an area which we haven't discussed, which I think should be considered. But thanks again for letting me come.
Awesome. No, those are really heartfelt insights. Thank you, Jeff. Okay, folks, thank you so much. This concludes the 2023 AI panel here at AUSA. I'd like to say thank you, and a heartfelt thank you to each of the panelists. Thank you so much for imparting the knowledge that you did today. That's really insightful, and sharing those perspectives is important. I'd also like to say thank you to the AUSA team for graciously hosting this event. Sharing different perspectives on AI is critical to our ability to make progress in this very challenging area. As we close here today and ponder the future of AI, let's remember that even the smartest algorithms still can't answer the age-old question of who let the dogs out. All right.
Okay, as we transition to our last panel, let's give this most esteemed panel another round of applause. You guys made my head hurt.